This video is about topics 4, 5, 6, and 7 in Unit 1, so the different cycles. So let's start with some of the basics. These are nutrient cycles, and key nutrients necessary for life regularly cycle through an ecosystem. We have 4 that we're going to study in this course. The availability and rate of flow of these nutrients helps to predict how productive an area is and how much life it can support. The 4 key macronutrients include carbon, nitrogen, phosphorus, and water. This is just a quick overview and by no means the full lesson. So if you need more resources, please refer to the videos on the College Board site. That will give you some of this in more detail. Key terms that you should know. Source is something that gives off a particular nutrient. A sink is something that has accumulated a particular nutrient, and a reservoir is something that contains a particular nutrient. These are all terms that you should be familiar with. We're going to start with the carbon cycle. Most of the cycle is between photosynthesis and aerobic respiration. So even though plants undergo respiration, we think of them as taking in carbon dioxide, and we think of animals as giving off carbon dioxide. We also have other ways that we give off carbon dioxide. Carbon dioxide is the key component of the carbon cycle, but it only makes up 0.04% of the composition of the atmosphere. When we have more carbon dioxide in the atmosphere, we have warmer temperatures, and when we have less carbon dioxide, we have cooler temperatures. Key things to know is that marine sediments that are mostly carbonates are a significant reservoir of carbon, and that fossil fuels are another significant reservoir. One of the problems we have is that we are taking that ancient carbon in fossil fuels and we are putting it into the atmosphere. If we left it underground, we wouldn't have the global warming problem that we have today. The nitrogen cycle, atmospheric nitrogen is the largest reservoir, but unfortunately, that N2 is inert and not usable for most forms of life. The things that I want you to take away from that is that microbes or bacteria are a huge component of the cycle. It's the only cycle that involves having bacteria as a component. Plants, and therefore consumers, use the nitrogen in the form of ammonia, ammonium, or nitrates. And lightning plays an important role in fixing nitrogen too. One of the important things about the nitrogen cycle is that it's a limiting reactant, which means that the world, especially water systems, are just waiting for nitrogen to show up. And when nitrogen shows up, it can cause an algal bloom, which will cause eutrophication. And when that algae dies, we end up with no oxygen in the water, and we end up with dead zones due to that. So eutrophication is a big impact of the nitrogen cycle. The phosphorus cycle, phosphorus is also a limiting reagent and can also cause eutrophication to occur. Its significant limiting factor, most solid contains little phosphorus compounds, so most solids don't have phosphorus in them. There is no atmospheric phosphorus, so this cycle turns and moves very, very slowly because there is no atmospheric component, and that's a key part of the phosphorus cycle. The main reservoir is rock and sediments, and phosphorus is added to the system as quickly as it can weather out of the bedrock. So it moves really, really slow, but it's very significant because the 2 things that plants need to grow or that it's going to cause eutrophication are nitrogen and phosphorus. And the last one is the water cycle. It's powered by the sun. The oceans make up the primary reservoir of water on Earth. That has the bulk of our water on Earth. The ice caps and the glaciers are second in terms of where most of our water is. And then for a recap, productivity and ultimately the abundance of life is dictated by several key macronutrients. The carbon cycle centers around photosynthesis and aerobic respiration. The nitrogen cycle requires microbes or bacteria to turn atmospheric nitrogen, which is not usable, into things that are usable, such as ammonium or nitrates. The phosphorus cycle moves in the slowest and its compounds are in the smallest amounts, making the ability of phosphorus a limiting factor. And the water cycle helps drive most of the other cycles. Again, this was a super quick overview, so if you need more information, you have to reference the videos that are shared on the College Board website.